This is the most violent place in the solar system. Nothing in the solar system should look like this. A moon covered in fire with volcanoes erupting hundreds of kilometers into space. When scientists first looked at the data from NASA, they thought the instruments were broken. Because this wasn't just a volcanic world. What they were seeing on Io, orbiting Jupiter, was something the solar system was never supposed to produce. I want you to sit with that for a moment. The solar system is 4.5 billion years old. It has had 4.5 billion years to cool down, to settle, to find its rhythms. The planets have done this. The moons, by and large, have done this. They formed from the same spinning disk of gas and dust that made our sun. They gathered themselves into spheres, they hardened, they quieted. Most of them look the way old things look, cratered, cold, worn by time. You can read the history of the solar system in those craters the way you read the rings of a very old tree. Each impact, each collision, another year written into stone. But Io has almost no craters. And that, more than anything else, is what should stop you cold. No craters means no memory. No craters means that whatever surface existed yesterday has been buried, melted, rewritten. Io is not old. Io is not settled. Io is not quiet. Io is, at this very moment, the most geologically active body in the entire solar system, more active than Earth, more active than Venus, more active than anything we have ever found. It is a world that is perpetually tearing itself apart and rebuilding itself from the inside out in real time while we watch. And I find that extraordinary. Because Io should not exist, not like this, not this raw, this furious, this alive. And the story of how it came to be this way, the story of why this small, battered, fire-drenched moon refuses to go quiet, is not just a story about volcanoes, it is a story about pressure. About what happens when forces far larger than you pull you in opposite directions, day after day, year after year, for billions of years. And it is, if you are willing to hear it that way, a story about what pressure does to living things, including you. But let us begin at the beginning. Let us begin with Galileo. In the year 1610, a man in Padua pointed a small telescope at the night sky and saw something that changed everything we thought we knew about our place in the universe. Galileo Galilei was not the first person to look at the stars through a lens, but he was among the first to understand what he was seeing. And on the 7th of January, 1610, he saw 4 small points of light arranged in a line beside the bright disk of Jupiter. He thought, at first, that they were distant stars, but the next night they had moved, and the night after that they had moved again. Not randomly, not like stars drifting with the rotation of the sky, but in a pattern, back and forth, orbiting Jupiter. He had discovered moons, not our moon, not the moon that has governed human imagination and calendars and tides. Since the first human being looked upward at the night, he had discovered that another world had moons of its own, that things moved around, things other than the Earth, that we were, perhaps, not the center of everything after all. The Church did not appreciate this. Galileo spent the last years of his life under house arrest for the crime of looking clearly at the sky and reporting what he saw. But the moons did not stop orbiting. And one of them, the innermost one, the fiery one, the one we now call Io, has been circling Jupiter without pause, without interruption, without rest, for 4.5 billion years. Io is roughly the same size as our moon. If you could stand on Earth and swap them, it would look about the same size in the sky. But that is where the similarities end. Our moon is grey and still and ancient, its surface shaped by impacts that happened billions of years ago. Io is yellow and red and orange and black, its surface shaped by what happened last Tuesday. Literally. The surface of Io changes so rapidly that images taken by spacecraft just months apart show entirely different terrain in some regions. Lava flows cover old features. New volcanic vents open. Entire mountains larger than Everest, appear and crumble and are buried in geological instants. And the volcanoes. The volcanoes of Io are something for which I genuinely struggle to find adequate language. There are over 400 of them actively erupting at any given moment. 400. Earth, in all its geological fury, has perhaps 50 or 60 volcanoes active at any one time. Io has 400. Some of them are venting sulfur dioxide gas in plumes so impossibly vast that they rise 500 kilometers above the surface. 500 kilometers. The International Space Station orbits Earth at roughly 400 kilometers altitude. These plumes would engulf it. They are reaching into space from the surface of another world, carrying material that rains back down and coats the landscape in a perpetual, lurid snowfall of sulfur frost. When Voyager 1 flew past Io in March of 1979, a young navigation engineer at NASA's Jet Propulsion Laboratory named Linda Morabito was checking the spacecraft's position using background stars in one of the images. She noticed something behind the limb of Io that was not a star and was not an artifact. It was an umbrella-shaped cloud, rising from the surface, glowing faintly against the black of space. She stared at it. She called her colleagues. Nobody could explain it at first. And then, slowly, the understanding arrived. They were looking at a volcanic plume, actively erupting, captured in a single photograph taken by a spacecraft already moving away at tens of thousands of kilometers per hour. It was the first active volcano ever detected beyond Earth. And it was enormous. Linda Morabito was 26 years old. She had been at JPL for 3 years, and she had just discovered something that overturned the scientific consensus about what the outer solar system looked like. Before Io, the working assumption was that the further you went from the Sun, the colder and deader things became. The outer solar system was supposed to be a frozen museum. Io declared loudly and unmistakably that the outer solar system had not received that memo. I think about Linda Morabito often when I think about discovery, about how it so frequently comes from someone who looks at an image and asks a simple question, "What is that?" Not "this cannot be right," not "the instruments must be wrong," but simply, "What is that?" Children do this all the time. They look at the world with clear, unfiltered eyes and ask what things are without first deciding what they are supposed to be. And then, somewhere along the way, most of us stop. We accumulate assumptions the way Io does not accumulate craters. We pile them up, layer upon layer, until the original surface of our curiosity is buried and cold. The greatest scientists, I have always thought, are the ones who somehow preserve that original surface, who keep looking at things as though seeing them for the first time. Now, I promised you an explanation of why Io is the way it is. And the answer is, to me, one of the most beautiful and terrible things in all of planetary science. It is Jupiter. Jupiter is the largest planet in our solar system. If you gathered all the other planets together and put them in a pile, Jupiter would still outweigh that pile by a factor of roughly 2.5. Its Great Red Spot alone, a storm system that has been raging continuously for at least 350 years, is larger than the entire planet Earth. Io orbits very close to Jupiter, dangerously close. And because Jupiter is so massive, its gravitational pull on Io is extraordinary, but that alone would not produce what we see on Io's surface. What produces Io's volcanoes is Jupiter in combination with 2 other large moons, Europa and Ganymede, that orbit further out. These 3 moons are locked in what astronomers call an orbital resonance. For every 1 orbit that Ganymede completes around Jupiter, Europa completes exactly 2, and Io completes exactly 4. 1, 2, 4. A perfect, repeating rhythm maintained with clockwork precision over billions of years. And because of this rhythm, Europa and Ganymede periodically line up with Io, and when they do, their combined gravitational pull gives Io a small but regular tug. A nudge outward, then inward, over and over again, with every orbit. Now imagine that you have a rubber ball in your hands, and you squeeze it rhythmically again and again. The ball deforms slightly each time you squeeze it, then springs back when you release. Keep doing this, and what happens? The ball gets warm. Not because of any external heat source, but because the repeated deformation of the material inside the ball generates heat through friction. Physicists call this tidal heating. The gravity of Jupiter and the resonance with Europa and Ganymede squeeze Io rhythmically, continuously, with every orbit. And the interior of Io, deformed and released and deformed again, generates heat, enormous, relentless internal heat. Heat that has nowhere to go but up. Heat that melts rock and forces it through the crust and sends it hundreds of kilometers into space. The volcanoes of Io are not a geological accident. They are a gravitational inevitability. They are what you get when something is caught between competing forces so powerful, so unrelenting, that the only possible response is to burn. I told you this was a story about pressure. I meant it. Think about what tidal heating requires. It requires Io to be caught between Jupiter's enormous inward pull and the outward nudges of Europa and Ganymede. If Io were free, if it were drifting alone through the outer solar system, far from Jupiter's influence, it would be cold and dead and cratered like everything else, unremarkable. Nobody would have made a program about it. But because it is caught, because it is held in this precise and relentless gravitational grip, it is the most alive place in the solar system. I have lived a long life, long enough to have known people who were themselves caught between forces, between expectation and desire, between duty and passion, between the world as they inherited it and the world as they wished it to be. And I have noticed that the people who produce the most extraordinary things, the most heat, the most light, the most sheer erupting creative force, are so often the ones who were caught, who were squeezed, who were not free in the easy, uncommitted sense of the word, but were instead held in a tension that gave them no choice but to burn. This is not a comfortable observation. The surface of Io is not a pleasant place. It is by any measure hellish, but it is alive. It is more alive than anything else out there, and the life comes directly from the pressure. Let me tell you what it would actually be like to stand on the surface of Io. You step out onto the ground. It is not rock, not in the familiar sense. It is sulfur, sulfur dioxide frost, dusted across the landscape in every direction, white and pale yellow. The sun, 5 times further away than it is from Earth, is a bright, cold star rather than the great warm disk we know. The temperature on the surface, away from volcanic vents, is around -130 degrees Celsius. Cold enough to make Antarctica feel like a summer's afternoon. But then you look at the horizon, and what you see is fire. Real, actual burning fountains of molten rock, spraying upward from vents in the crust, cascading back down in slow arcs in the low gravity, coating the surrounding plains in rivers of lava that glow red and orange. The contrast is absolute. Cold, frost-covered plains, and then, half a kilometer away, a wall of heat and fire that would incinerate you before you could take 3 steps toward it. And above you, above everything, Jupiter. Jupiter fills the sky. It hangs there, banded in orange and cream and brown, enormous beyond comprehension. The tidal forces that cause all of this, all the fire, all the mountains, all the erupting sulfur, come from that object hanging above you. You can see the cause of everything you are experiencing, and it is beautiful, and it is terrible, and it is utterly indifferent to your presence. The lavas of Io erupt at temperatures of up to 1800 degrees Celsius. These are temperatures that Earth's current volcanic activity simply does not reach. These are temperatures more reminiscent of the early Earth, 4 billion years ago, when our young planet was still largely molten and the volcanic activity was global and continuous. Io is, in this sense, a window into the past, a working model of what Earth was like before it grew up, before it cooled down, before it became the temperate, moderately well-behaved geological entity that it is today. When you look at Io, you are seeing Earth as it was in its infancy, raw, violent, unfinished, terrifyingly alive. I find this moving. The idea that we can look outward across the solar system and see our own past reflected back at us in the fire of another world. We carry our history inside us, in our DNA, in our earliest memories, in the stories our parents told us, but we also carry it out there, written in the geology of other worlds. The solar system is a family album, and Io is the photograph of Earth before any of us were born. Now I want to speak about Io's neighbor. Because Europa, the next moon out from Io in Jupiter's family, the moon that gives Io its gravitational nudge, the moon partly responsible for Io's hellish existence, Europa may be one of the best candidates for extraterrestrial life in the entire solar system. The irony here is rich enough to stop you in your tracks. Io is a fire world, radiation blasted, volcanically shredded, inimical to life in every way. Europa is an ice world, its surface frozen solid, its appearance smooth and cracked and ghostly white. They are neighbors, they are gravitationally intimate, and they could not be more different. But beneath Europa's icy surface, there is thought to be an ocean, a liquid water ocean, kept liquid by the same tidal heating that powers Io's volcanoes, though at a much reduced intensity because Europa is further from Jupiter. This subsurface ocean may contain twice as much liquid water as all the oceans of Earth combined. And at the bottom of it, where the ocean meets the rocky seafloor, there may be hydrothermal vents, hot springs, like the ones we find on the deep floor of Earth's oceans, where superheated water laden with minerals rises from the rock below. On Earth, those hydrothermal vents support some of the most extraordinary ecosystems anywhere on the planet. Tube worms 3 meters long, albino crabs, mats of bacteria so thick you could scoop them up in handfuls. All of it living in total darkness, powered not by sunlight but by chemical energy from the rock. Life does not need the Sunday. Life needs water and heat and chemistry. And Europa has all three. The connection between Io and Europa's potential habitability is direct and profound. Without the orbital resonance that causes Io's tidal heating, Europa's tidal heating would be insufficient to maintain a liquid ocean. Without Io burning at full intensity in its closer orbit, Europa might be frozen solid all the way through. Io's suffering, in a sense, may be what makes Europa a potential cradle of life. The violence of one moon sustains the possibility of another. Even in the solar system, destruction and creation are bound together in ways you do not always see until you look carefully at the whole. I want to stay just a moment longer with something I find particularly haunting: how little time we have spent looking at Io properly. We first confirmed Io's volcanic activity in 1979. In the 45 years since, we have sent precisely 2 spacecraft close enough to study it in detail. 2. For the most geologically active body in the solar system, a world rewriting its own surface in real time. And yet our resources for exploring the solar system are finite, and every mission involves choices, and so Io has waited. There is a metaphor here too. We do this with extraordinary things in our own lives. We note them, we acknowledge their importance, we mean to return to them, and then we do not, because other things press more urgently on our attention. The erupting moon waits. The unanswered question waits. The conversation we have been meaning to have waits. And the years go by, and the surface of things changes, and what we might have seen clearly at one moment becomes harder to read at another. Io's surface is being buried and rewritten, even as we debate when to look. Some things will not wait forever. Io does that to me. The idea of it. A pizza-colored moon hanging in the shadow of Jupiter, covered in fire, surrounded by radiation, erupting into space from 400 simultaneous volcanic throats, rewriting its own surface in real time, burning because it cannot do otherwise, burning because the forces around it demand it burning so ferociously that it keeps its neighbor's ocean liquid, and perhaps keeps whatever lives in that ocean alive. That image does to me what the best things in the natural world have always done. It makes me grateful. Grateful to be alive at a time when we know this. Grateful to be the kind of creature that can look across the solar system and ask why things are the way they are. Grateful that a young woman in Pasadena looked at a photograph in 1979, saw something she did not expect, asked a simple question, and changed everything we thought we knew. We are remarkable. For all our faults, we are remarkable precisely because we look, because we cannot help looking, because the sight of something extraordinary draws us forward, despite the distance, despite the cost, despite the uncertainty. We build spacecraft and we point them at the dark, and we wait patiently for the answers to come back at the speed of light. And when the answers arrive, they are always stranger and richer and more wonderful than we expected. Io is stranger and richer and more wonderful than anyone expected. It is a world that should not exist the way it does, and yet here it is, burning in the dark beside Jupiter, 400 volcanoes erupting simultaneously, impossible and real and extraordinary. The things that should not exist are almost always the things that teach us the most. The anomalies, the exceptions, the places that break the rules, they are where the real knowledge lives. They are where our assumptions come undone and something truer takes their place. So ask the question even when you do not expect to find an answer. Keep looking even when the distance seems impossible. Stay curious even when, especially when the world has given you every reason to stop. Io has been erupting for 4.5 billion years. It will go on erupting for billions more. Long after every human being alive today is gone, that small moon will still be burning in the dark beside Jupiter, caught in its gravitational embrace, turning pressure into fire, turning fire into mountains, turning destruction into creation, over and over and over again. There is something in that I find deeply, quietly comforting. That the universe contains this. That it contains this, and also contains us creatures small enough to fit in a chair, large enough to wonder at the cosmos. That we are, for this brief and improbable moment, here together, in the light, looking outward. Io is still erupting. Right now, at this very moment, as you hear these words, hundreds of volcanoes on a moon, 500 million kilometers from here, are sending material into space. The signal is out there. All you have to do is look. I have been thinking these past few years about what it means to pay attention. Really pay attention, not the half-attentive, screen-glancing, half-present version of attention that modern life so easily produces, but the deep, patient, fully committed kind. The kind that Linda Morabito brought to a photograph in 1979. The kind that Galileo brought to a night sky in 1610. The kind that a naturalist must bring to a patch of forest, or a tide pool, or a stretch of savanna, if they want to see what is actually there, rather than what they expect to find. This kind of attention is, I believe, one of the most important things a human being can practice. And it is harder than it sounds. It requires, above all, a willingness to be surprised. A willingness to set aside what you think you know and simply look. To let the evidence speak before your interpretation does. To follow the data even when it leads somewhere the theory did not predict. Io is a lesson in the importance of following the data. The data from Voyager's 1979 flyby contained the truth about Io's volcanic activity before any human being knew what that truth was. It was sitting there in the images, patient and clear and undeniable. All it needed was one person willing to look without assumption, one person who had not yet decided what was possible. I wonder how much truth about the world is sitting in plain sight, waiting for exactly that kind of attention. Truth about the people we live with, the places we inhabit, the choices we make every day without examining. Truth that has been there all along, transmitting faithfully, but going unheard because we have already decided what the signal is supposed to say. There is a Japanese concept I have been reflecting on, the idea of beginner's mind. The Zen teacher Shunryu Suzuki wrote that in the beginner's mind there are many possibilities, but in the expert's mind there are few. This is, I think, one of the great paradoxes of knowledge. The more we learn, the more we risk foreclosing the very openness that allowed us to learn in the first place. Expertise is invaluable, but it must be held lightly, always kept in tension with the readiness to be wrong. Always balanced against that original, childlike willingness to ask, what is that? The scientists who study Io hold their expertise lightly. They must, because Io keeps surprising them. Every new spacecraft visit, every new set of images, every new dataset reveals something that the current model did not fully predict. The volcanic plumes are larger than expected. The lava temperatures are higher than expected. The mountains are in different places than the models suggested. The heat escapes in patterns that the simplest theories cannot account for. Io is a world that will not be pinned down. A world that keeps offering new information, keeps revising the picture, keeps insisting that the last word has not been spoken. I admire that in a world. I admire that in a person too. Io sits at the edge of what we have been able to examine closely. But the Juno spacecraft's recent flybys have brought it back into focus, crisp and vivid and volcanic and strange. The images returned show lava lakes the size of small seas, their surfaces crusted with cooling rock constantly broken and overturned as fresh magma wells up from below. They show volcanic plumes caught mid-eruption, columns of sulfur dioxide rising and spreading at altitude into perfect umbrella shapes. They show mountains casting long shadows across plains of frost, their flanks scarred by collapses, their peaks disappearing into volcanic haze. And I look at these images and I think, we made instruments sensitive enough to capture this. We aimed them at exactly the right place. We interpreted what they showed us correctly. And now, sitting in front of a screen, anywhere on Earth, you can see the surface of a volcanic moon orbiting Jupiter in something close to real time. That is not nothing. That is, in fact, one of the greatest things our species has ever done. Not the building of empires, not the accumulation of wealth, not the conquest of territories, the looking, the pointing of instruments at the dark and the willingness to be changed by what they find. Keep looking. That is all I ask. At the sky, at the earth, at the people beside you, at the places that seem most hostile and most strange, because those are so often the places that hold the most extraordinary truths. Io taught us that fire can exist in the cold outer dark of the solar system. It taught us that pressure creates life, or at least the conditions for life. It taught us that a frozen museum can contain right in its heart a world more alive than anything we imagined. What else is out there, waiting to be seen? What else is transmitting patiently, faithfully, in frequencies we have not yet learned to receive? I do not know, neither do you, neither does anyone. And that is precisely the point. That is precisely the beauty of it. Io is still erupting. The signal is still out there. Go and find it.